My apologies, on the last video I mistakenly ended the video and I don't really want to start this all over. So we'll pick it up where we left off. We're at the point where if r is equal to 0, on the left side we end up with 0 times x plus m plus 0 is equal to, on the right side, 3 plus 2m times x plus 2b plus 3. And so we still had 3 plus 2m is equal to 0, which means that m is equal to negative 3 halves still. However, now m, the constant term, is equal to 2b plus 3, the sum of the constant terms. But if m is equal to negative 3 halves, subtracting 3 from both sides gives us 2b is equal to negative 9 halves, and finally that b is equal to negative 9 fourths here. And this was all with the assumption that r is equal to 0. So there's a lot of answers there. If you go into the scoring guidelines, there's only 3 points for this whole section here. And you get 1 point, excuse me, just for equating the derivatives, the two derivatives to each other. That is, the derivative of the solution, which is m plus r e to the rx, is equal to dy dx, 3x plus 2y plus 1, and plugging in mx plus b plus e to the rx, etc. for y. So just doing that got you 1 point, and I guess of those 6 values, somehow they divided up 2 more points in there. So if you didn't see the second solution, that r could also be equal to 0, you still probably would have gotten most of the 3 points for that problem, but r could be equal to 0. So hopefully that makes sense, and you can kind of see how this particular problem might work itself out. And that's it. We're going to wrap up this problem here.